Okay, today, folks, we are going to learn how to multiply a binomial times a binomial. So multiplying binomials is very special, and you will be doing this a lot over your high school and college mathematics courses. What you have to understand is a binomial is a polynomial with two terms. So when you have a binomial times a binomial, because you're doing 2 times 2, there are actually 4 multiplications that take place. The first method that we're going to study for learning how to multiply a binomial times a binomial is called the rectangular array method, but in short, I like to call it the box method. So what I'm going to do is I'm going to draw a box, and it's going to have 2 rows and 2 columns. So I call it a 2 by 2 box. And then what I do is on one side of the box, I put the terms of one of the binomials. And it really does not matter if I put these terms on the left side or the top side. And technically it doesn't matter the order I put them in. I like to put them in descending order. So I have my 2x and then negative 3. And then on the top of the box, I put the terms of my other binomial. Anytime you have a minus in front of one of your terms, always put it with it because that makes that number or that term negative. Then what we do is we go through and we multiply what is on the outside of the window and put the product in the box. So for this first little window right here, I would say 2x times x, and that would give us 2x squared. For this next window, I would say 2x times 2, so that would give us 4x. And then I'm going to come down here to the bottom row. So negative 3 times x is negative 3x. And then this last window in the bottom right corner, negative 3 times 2 would give us negative 6. After we multiply all our terms together, and y'all can see how there's 4 multiplications that took place, we want to combine like terms. So one way you can do this is just copy your rows right outside of your box you have there. So in the first row I have 2x squared, and then I have plus 4x because that's positive. And then I'm going to copy my next row, but when I do it, I'm going to line up my like terms. So I'm going to put negative 3x minus 6. Then all we have to do is add them together, and we only have 2 terms here that are like terms. So 4x take away 3x is positive 1x, or you can just say plus x minus 6. And there's your final product, and you've multiplied those 2 binomials together. Another way that you can do it so that you don't have to do as much work and copy the terms outside the box is you can just look at the box and find the like terms inside the box. So if you have your polynomials in descending order, a lot of times it'll be these terms that are diagonal from each other right here. And I kind of think about it as like looking at this like a big plus sign in the middle. Okay, I've got my 2x squared, which I would put right here. And then I'm going to say 4x plus negative 3x, which gave me 1x, so I'd write that right here. And last but not least, negative 6. And there would be our final answer. Okay, so pause the video. In just a second, write down the next problem. Try to do it with your box, and then when you're done, start the video back. All right, so again, you just draw your 2 by 2 box because it is a binomial times a binomial. It does not matter if you take the first binomial and put it on the left side and the second binomial and put it on the top, or vice versa, because multiplication is commutative. So 2 times 3 and 3 times 2 is going to give us the same answer. So that's completely up to you. And then we'll multiply our windows together. X times 2x gives us 2x squared. X times negative 1 gives us negative 1x. 3 times 2x gives us 6x. And 3 times negative 1 is negative 3. Again, I think it's a really good idea to put that 1 right there so when you go to combine your like terms, you see it. And if we look right here, these 2 terms are like terms. So when we put that together, that is going to give us 2x squared. 6x take away 1x is positive 5x minus 3. And there's our final answer. All right, so another way that we can multiply binomials is using the distributive method. So what I'm going to do is use the exact same 2 binomials that we just did with the box method, but show you how to do it with the distributive method. So the first thing I'm going to do is I'm going to copy the problem. So we have 2x minus 3 times x plus 2. When using the distributive method, I have to make sure I distribute all the terms in the first polynomial to the second polynomial. So here's how this would look with the distributive method. I'm going to say that's 2x times x plus 2, and then minus 3 times x plus 2. So again, I'm distributing this 2x to this binomial, and then this negative 3 to this binomial. All right, so from there, you just distribute. So we have 2x times x, which is going to give us 2x squared, and then 2x times positive 2, which is 4x. Then when I come over to the next part, I'm going to distribute the negative 3. Make sure you take the negative with your 3. So negative 3 times x is negative 3x. And negative 3 times positive 2 is negative 6. Then if we look right here in the middle, we have like terms. So when we go to combine our like terms, we have 2x squared. 4x take away 3x is positive 1x minus 6. And what you see is we get the here and this answer here are exactly the same. Also, if you look at the terms that we got right here, the 2x squared plus 4x minus 3x minus 6, it's the same terms that you had in the box right here. So they're just two different ways of approaching doing to multiply binomials together. I will say most students prefer the box method over the distributive method, but I always have a couple of students that like the distributive method too. And so it really doesn't matter as long as what you're doing works for you. I will say that if you are struggling with the distributive method, I would go back to the box method. Okay, so try the next one again, but this time try it using the distributive method. Pause the video when you're done. Start the video back to see how you did. All right, so looking at this, what I've done is I've taken this x right here, and I've multiplied it by the 2x minus 1. And then I've taken the 3 here and multiplied it also by the 2x minus 1. So we make sure we distribute. X times 2x is 2x squared. X times negative 1 is negative 1x. 3 times 2x is 6x. 3 times negative 1 is negative 3. And then we combine like terms here in the middle, so we end up with 2x squared plus 5x minus 3. Okay, so the last method that we're going to talk about today is called the FOIL method. And the FOIL method is probably the quickest way to multiply a binomial times a binomial, but it can only be used when multiplying a binomial times a binomial. We cannot use it for multiplying monomials times polynomials or like binomials times trinomials. Notice there are 4 letters in FOIL, F-O-I-L. That's why it only works when you multiply a binomial times a binomial. It pretty much is telling you what to multiply so that you make sure you take care of all 4 multiplications. And it saves you a step from that distributive property we just discussed. So let me show you what this means. Looking at this binomial times this binomial here. If I went through it, I would start with the F. What that means is I want to multiply the first term of each binomial. So I want to multiply the 4c times the 2c. So if I say 4c times 2c, that would give us 8c squared. The next letter in FOIL is the O. And what that means is that we want to multiply the outside terms together. So if I look at this big problem, when I say the outside terms or the outer terms, I'm talking about the 4c and the negative 3. So right here I would say 4c times negative 3, which would give me negative 12c. The next letter in FOIL is I. And what that means is it wants us to multiply the inner terms or the inside terms. So what it's talking about here is multiply these 2 terms on the inside of this problem, that negative 5 and 2c. So if we say negative 5 times 2c, that would give us negative 10c. And then the last letter in FOIL is L for last. What that means is I want to multiply the negative 5 times the negative 3. So negative 5 times negative 3 would give us positive 15. And then just like the box method and the distributive method, once you've done all that, you would then combine like terms. And in this case, I do have like terms right here in the middle. So our final answer would be 8c squared, negative 12 and negative 10 is negative 22c plus 15. And that would be our final product. All right, so that seemed really long and drawn out. Of course, we would do that much faster in a normal problem. So let me kind of go through it with you where it goes a little bit quicker. So let's look at this next one. All right, so we're going to go through and practice doing the FOIL method. So for FOIL, first times first. That means I'm going to multiply x times 3x. X times 3x is 3x squared. Next, I go to my O, my outer terms. So my outside terms are the x and the negative 1. So x times negative 1 is negative 1x. Next, I want to multiply my inside terms. So our inside terms are positive 5 and 3x. So that would multiply to give us 15x. And last but not least, I want to multiply my last terms. So our last terms are 5 and negative 1. 5 times negative 1 is negative 5. And then after we go through and we do our FOIL, we look, do we have any like terms? And in this case, we do. We have a negative 1x and 15x, so we combine those to get 3x squared plus 14x minus 5. So if you like FOIL, you can do it pretty fast. But again, I will say that if you struggle with it, you're like, ooh, I cannot follow along with that, I would just use the box method. The great thing about the box method is you won't forget to multiply anything together, because you would have an empty window. Also, understand there's not always going to be like terms. Sometimes you will not have like terms. So why don't you try the next problem, pause the video, when you're done, start the video back. Okay, so let's check this one out. 3y squared times 2y. So when we do 3y squared times 2y, that is going to give us 6y cubed, because in this case, y squared times y is going to give us that y cubed. Then we're going to do our outside. So that's going to be that 3y squared times positive 1. So that would be plus 3y squared. Then we want to do those insides. So that's that negative 2 times 2y. So that would give us negative 4y. And then last, we're going to do this negative 2 times positive 1, which would be negative 2. Notice in this case, we do not have like terms. We have a y cubed, a y squared, a y, and a constant term. So if it doesn't have any like terms, you're done. Most of the time you will have like terms, but sometimes you won't. All right, last problem of the day. Let's go back and look at a geometry problem again, like we've been doing with these other ones. It says, find the area of the shaded region. So I love this problem because it kind of makes me think about, what landscapers do. Think about if they are going to sod a yard and they have the size of the whole yard. Of course, they're not going to buy sod for the entire yard because there's probably a house on that yard. And along with other things, there's probably trees or a driveway. And they have to subtract all that out of their total area. So that's kind of like what we're going to do here with our polynomials. To get the area of the shaded region, I'm just going to kind of abbreviate this. We would need to find the total area of the whole figure and then subtract out the area of the non-shaded region. In other words, in this case, the white part in the middle. So to do that, we need to find the total area, and then we need to find the area of this white little rectangle in the middle, and then subtract them to get the area of the shaded region. So here's kind of where we put together what we've been doing today with the last 2 days. So let's start out by getting the total area. So to get the total area, or the big area, we're going to multiply x plus 2 times 2x plus 3. And at this point, you have to decide what is the best method for you. Do you like the box method? Do you like the distributive method? Or do you like the FOIL method? And whatever works for you, that's the method that you should use. So I'm going to come over here and do the box method for this one. So I have x and 2, and then 2x and 3. So x times 2x is 2x squared. X times 3 is 3x. 2 times 2x is 4x. And 2 times 3 is 6. And then if we look right here, we can see we've got these like terms, that 3x and 4x. So we're going to add those together. So we get that the total area is 2x squared plus 7x plus 6. All right, so now I'm going to find, so now we need to find the area of the non-shaded rectangle in here. In other words, the white rectangle. So to do that, length times width, we're going to say x times x plus 1. Notice in this case, we're not multiplying a binomial times a binomial, so there's no reason to draw a box or to distribute, or sorry, no, we will distribute, but use the double distributing or to do FOIL. All we have to do in this case is just straight up distribute. So we're going to say x times x, which is going to give us x squared, and then we're going to say x times 1, which is going to give us plus 1x. All right, so now that we have our big area and our small area, we need to find the area of the shaded region. And so to do that, we are going to subtract this non-shaded region, this white area, from the total area. All right, so what I'm going to do is I'm going to copy down my total area, which was that 2x squared plus 7x plus 6. But remember, I want to subtract the x squared plus 1x. And whenever we subtract a polynomial, we have to change its signs. So when I write this down, I'm going to change it to minus x squared minus 1x. You don't want to just subtract the beginning of it. You want to make sure you subtract all of it. And so that I can see this 1 here, I'm going to put it there so I make sure I don't make a mistake when I subtract that. So 2x squared take away 1x squared is just going to leave us with a 1x squared. 7 take away 1 is 6x plus 6. Remember, folks, when we are adding and subtracting polynomials, we only add and subtract the coefficients. The exponents do not change. Please be careful about that. I was looking at some of y'all's answers from the first day's assignment, and I mean, I had powers up to the 16th power and some really, really crazy stuff in there that shouldn't have been happening because y'all are adding exponents when you shouldn't. All right, I hope this helps, and complete your lesson, your assignment today in Delta Math, and then come back for our next lesson tomorrow.